Continuing to build out the diagnostics for the IO on the Rogue rig, and I think today's is challenging for me, so I'm hoping that I get some good revelations out of this one. I alluded to it a little bit yesterday is that, whoops, I'm pointing at the wrong module. The 5069 OBV8S. Which one this is, the Rogue rig that we can simulate brakes on. And there is a few faults that you can get on this module. I keep pointing at the wrong module that are really difficult to troubleshoot. As in, if somebody flipped a switch on me blindly, what happened? I mean, I spent several hours on this one switch, and actually it stumped two groups of technicians, and afterwards they're like, yeah, we have this problem, and all we know to do at this point is just start pressing these stops, pulling out, hitting the reset, cycling power, doing all these things. So what I want to try to do is add those same diagnostics I did yesterday to it. And I'm hoping that something really pops out obvious is wrong with this. One to prove out, there's a lot of people even said, all this diagnostics you add, chances are it won't be used. You didn't say it wouldn't be used in that sentence. And so in the Studio 5000 program over here, we have the 5069 OBV8S, whatever, safety output module. That's the one I really want to focus on. So that's going to be local colon 4. And it is an output module, so you're usually thinking local colon 4 colon O, but we want to try to read things about it. We want to see what its status is, and that is going to be local colon 4 colon I. And yeah, I'm still trying to figure out exactly an effective way to use this sequence count, but I think that's an important piece that's being left out in our machines. This basic diagnostics active. Actually, I didn't even do that on the last one, but I probably should have. But okay, really right here, each one has a read back, a fault, an uncertain, a short circuit, field power off, and status. I need to look these up. All right, so really interestingly, I'm struggling to find that right documentation to figure out exactly what these means. I mean, I can guess, but I shouldn't have to guess. Maybe somebody can help me figure out where to find this documentation, but okay, we're gonna do some guessing now. I'm really gonna guess that readback is exactly that. It's reading the state of the output right now. Fault means it has a fault. I'm still uncertain about what uncertain means, but okay, short circuit, field power off, got those. Then we have status, which status is a 1 right now. And I am gonna have to crazily assume, I guess, that 1 is happy. Because right now, all of them, here's where, see how I'm trying to hit all these arrows? This is one of those times. Right click local colon 4 colon I and expand all members. Now we go down through here, we can scroll really fast now, and yeah, all of our, nope. Number 6 is not a 1. Number 7 is not a 1. And I believe those are actually off right now. So if we go on down to local colon 4 colon O, 7 is off, 6 is off. All right, so I'm gonna go press the E-stop. Now, if we scroll back up to our statuses, Well, so I've got to find the documentation. I don't even understand what status really means, I guess. Okay, this maybe it was on me being this difficult, but I finally found the Compact Logix 5000 Digital I/O Modules User Manual. And, okay, there's the fault, which I think this safety input fault recovery, that's going to be important by the end of this. And there's the uncertain. This tag is set to a 1 when the module has reached its critical operating temperature or higher. Really? It's just a temperature warning. That'd been nice to know. Okay. Well, that is important, but okay, uncertain is high temperature. I get short circuit, I get field power off. Okay, and then where's status? Status, PT00 status. Oh, I guess I jumped to a test. Okay, I scrolled down with my eyes. I assume it's the same. Let me make sure. Where's uncertain? Point uncertain. Still, yeah, critical temperature, no load, short circuit. Status. Well, it says 6 and 7 are bad right now. Safety, oh, safety IO. Well, yeah, it's saying that right now, 0.6 is bad. Now, I know 6 and 7 aren't even used, but still, they shouldn't be bad. Let's go check them out. So I'm going to double click back on this. 6 and 7, point mode is not used. Huh. Folks, I don't know what to make of that. I mean, 6 and 7, yeah, they're not used, but apparently that makes it status angry. All right, well, let's get back to square one, because the whole goal here is that means I want to know, I think what I want to do this time, well, I would definitely use this fault, and it's definitely saying I have a fault on 6, but I don't have a fault on 6. Well, let's hit the little diagnostics. Maybe I do have a fault on 6. Why's my little, am I offline? No, not offline. Well, that's strange. I can't even get to, I can't even click on 6 or 7's diagnostics. All right, since they're not used, I think maybe that's why it throws that fault. Okay, can't figure them out. We'll move on to these. And really, our goal here, okay, now that no doubt, so this is a flashing output right here. So the read back, that's reading back the value. And I'm guessing if they don't match, we'll get a fault. So the first thing I want to do is I'm going to create that same fault that I've been running into. Okay, so our output module looks very angry at this point. And so that's what we're trying to figure out is, how do we figure out why it's angry inside Studio 5000? Also remember, when you're looking at the OBV8S, they're in pairs. So the first 2 terminals are output 0. The second 2 terminals are output 1. Probably while I'm at it, I need to work on this little twitchy thing eventually. So we'll scroll up to output, actually we'll stop by output 3 along the way. Output 3 looks happy. Output 2 looks happy. And output 1 has a fault. And okay, here's what I was really curious about is there is no, oh, actually, this is the important one here, I think. So that's half the battle, is figuring out when to put what in. So we have a read back of 1. And on this one, we also have a read back of 1. Now this is our output read back. So if I'm not putting a 1 on it, then I should not be getting anything back. So we go down here and let's make sure output 0, definitely off, and 1 is definitely off. So now here's where, okay, how complicated do you make your diagnostics? I'm not sure. I believe well, is the fault good enough? And I think here, I don't think we could think through all the combinations. I think knowing we have a fault on output 0 or 1 would be good enough to start with. So I'm going to add those to that fault code we did yesterday, and we're going to see how we would work through it. So I'm going to go down over here to diagnostics, and we'll go way down here to where we ended yesterday's video. And I'm going to do that fine copy and pasting thing. And we're going to modify this to local:3:I. And then we want PT0. I think we want PT0. Nope. What do we want here? I think we do want this fault. I was thinking I could do the overall diagnostics active, but especially for logging this, I think this is going to be a better deal. Now, even as I was doing that, I was like, why does this feel wrong? That's local colon 4. Now, arguably this should be in there too, but we're working on this output module. And so we're going to go down here to PT00. That's why I hesitated right here. It's like, where's my readback and everything we were just talking about? There we go. We get that fault. And then we're going to do a little copying and pasting. So that actually gets us 4 alarms because we have 6 and 7 down there. And then we have 0 and 1, which are the ones we actually need to pay attention to. Now, 6 and 7, they would have shaken themselves out during our startup and commissioning because they're not used. And here's a good example. You know, a lot of people are like, well, why would someone put an AFI in? Well, you know, if we're kind of OCD and we want all this laid out and we don't know if we're going to use 6 and 7 later, yeah, I probably would. I mean, here's a perfect example where I would do an AFI. So I would go over here to my program control category. Oops, it up there where you can see where I'm at. And then up here we do have the AFI, which is an always false instruction. It does not disable or wrong, and we have a video talking about that. But yeah, we would do that. And yeah, this is why you have 50 warnings in your program. And I know we could shut those off, but nobody ever does. And, oops, what did I do? I have no idea what I just did. But I think I drugged that down by accident. I'm trying to drive with one hand, and I must not have got my finger all the way on the control key. There we go. So now this is what it would be like when we had that error. And okay, that would lead us here. And honestly, I don't think I would put much more description on these. So then I would need to figure out what 0.00 and 0.01 is. So we do the good old right click and you get options and we would monitor it. And then I probably would go down to the output section of it and find out that's the VFDs S1 and S2. Kind of coincidentally, this has nothing to do with safety that's causing this. One of you asked, actually when I was highlighting the unfamiliar machine not too long ago, there's 40 switches. They're like, well, how do you end up with 180 brakes? Well, these are the ones. I mean, and twice now we have ended up in this situation. There's nothing wrong with the safety on this right now, but we have caused an issue trying to troubleshoot the other issue that has snowballed into now we have a safety issue. So now going back up, I really don't think this would be that apparent what's wrong. I don't think anybody would ever see this readback error. So let's go see what we could see over in our module properties. So we're going to hit the diagnostics on 0. Oh, all right, now what's going on here? I can hit 5s. All right, I'm just going to hit the OK button on this, and we're going to go right back into it. I have no idea. I've been having all types of issues with module properties since they put those graphics on a lot of them. There we go. Works perfectly fine now. Okay, so tells me a fault exists. Tells me my field power is present. I don't have a short circuit. I don't have an overload fault. We're not short-circuited to a ground fault. We do have an internal fault. Yeah, see, this one is really difficult to troubleshoot because even here, I don't see anything that's going to help us out. Ultimately, the issue is this readback fault. I mean, this was so, I don't think this would ever jump out. I don't think you could go to the module properties and find it. I think that we do have to think into the future and put that in as an alarm. How do we get a readback fault? It's really easy. All you do is either you have a bad component that is letting feedback come onto that output, or somebody puts a jumper wire on a safety circuit. This is an important alarm. And even, I Googled for quite a while. I didn't think I wanted to watch me Google, but I couldn't find I cannot troubleshoot this with Google. Now, ultimately, I probably only care if this is a 1 and our output is a 0, but really we care if they're mismatched. So I'm going to drop that rung down. And yeah, we're going to go look for a 1 in. And the first thing we want to know is local colon 4 colon O dot pt 00 dot data a 1. And we don't see feedback. So that would be I dot pt 00 dot readback. Okay, since I can't decide, I am going to make this one a branch. We're not, just so we see a variety of them here, and I can't decide whether this one right here is important. So we're going to grab both of those. We're going to paste that down, and we are going to drop the opposite in. So really, if they're mismatched, then we're going to go ahead and set an alarm on that. Now, one thing, and I didn't really address yesterday, and I'm not going to address today, because really I'm just doing some discovery here, is in the end, we need some debounce time, or I may be able to pull, I think I'm probably going to do that over an ignition. I probably am going to let these kind of scatter. I'm not sure about that yet. But this is going to alarm for a split second every single time we do it. And actually, I'm thinking through how I would do this in a video. I would probably show that in an actual video about how to do this. But that's interesting. Why? No, these are backwards. If we tell it to turn on, we should see the matching feedback. Nope, that's the happy condition. That is the sad condition. What have I done wrong here? Why does this look? Oh no, we're in fault right now. That's exactly what it should look like. So I'm gonna do a little copy and pasting. Now in the end, here is a good example where we're gonna have to have some debounce time, because this right here is gonna cause nuisance trips. Actually, no, I can fix this, because we also have our fault. So the first thing we need to know is that we had a fault, and then that will give us our readback alarm. So I'm gonna rung edit this one, and we'll go look for a 1 down, and it's close to that, so we'll double click on it. And yeah, this first thing we need to know is, are we faulted? So we have a fault, and these don't match. That's when we throw that alarm out, and that'll keep nuisance trips from happening, I think. So we'll do a little more copy and paste them. Now this is one of those where, yeah, we kind of had to think about, are we going to end up with multiple alarms? Oh, well, look at there. I spelled that wrong. Here's one of those bummers, and I don't know why. I can't edit this with the safety locked. But okay, back to what I was thinking is, that tells us that we are getting a readback alarm. Only on. Okay, so here's a good example. If I'm understanding this right, and I don't think I need to make sure. Nope, I got to copy. Oh, here's the downside to copy and pasting. It should be local colon 4 colon O, local colon 4 colon I. I just copied and pasted that wrong all the way through, so I need to fix that. Okay, yeah, I thought I should have had both of these faulted. That looks a lot better now, but now we have a readback fault. We have a very specific fault on both output 0 and output 1, but we also have that generic fault. So we don't want this fault if we have this fault. So we need to do a little more copy and paste, and hopefully accurately this time. Now, how do you make this thing permanently just go away? It doesn't matter how many times you auto hide it, unpin it, do all types of things. It always comes back. But now we don't have that alarm. Now I gotta admit, now I'm thinking, I had a couple thoughts on my mind. Is one, they're still getting a little more info over here. So I'm wondering if there isn't a GSV that maybe has some better data. That might be something to dig into at some point. But also, if there isn't, I would probably eventually can this into some type of add-on instruction. But now we have 2 singular alarms. So we're only halfway there though. So I can fix the alarm. So first thing I'm gonna do while we're staring at this is I'm gonna fix this alarm and we're gonna see what changes. All right, so our alarms drop out. We should be super happy now. But now if we scroll up, we still have our general alarms on them. This is probably the piece I've overlooked every time we've tried to run this fault exercise. So now the question is, why are we still faulted? So we're gonna right click that, and first we'll just monitor it, see if we can get any more info, but no, we just have a singular fault. So now we'll go over here on the OBV8S points, and we're going to go to point 0, and it says we do have a fault present. It says it has an internal fault, gives us a timestamp, and this might be good to be able to extrapolate. Actually, I would say this is going overboard. Really, when we're investigating what the world's going on, that's when I probably would just go here and write that down. It is not really clear why this is faulted now and what we need to do. So let's go to the good old help file. And it just shows whether a fault is present. All right. Well, that wasn't a good old help file, I guess. That was more of blah. All right, well, we got the manual open over here. And the channel is inaccurate and cannot be trusted for the application. For more information, see that. Now I'm actually going to right click. I think this is what we need. Oh, I can't right click that. Okay, so what page am I on? I'm on page 130. We're going to go look at this. I don't think I ever saw that uncertain, but all right, field power loss, no load, or short circuit. So now, I guess now that none of those exist, that's when we're in the situation on page 130 that we need to reset this module. I'm not sure about that yet. I need to exercise this quite a few more times probably. But all right, safety input recovery. If an error is detected in the safety input, remains off, to activate the safety input data again, remove the cause of error. I've done that. Place the affected inputs in the safe state. Allow the input error latch time to elapse. After these steps are completed, the IO. Well, that didn't work. Because, let's go back to 130. Let's read back. Oh, no. And see, here's where we end up every time. And this is why everybody's like, oh, just cycle power on it. And they keep cycling power on it, whether they fixed it or not. Unless maybe magically it is working now. It has been a while. Nope. We still got a fault. Do we just try to run it again? I know that's wrong, but let's try it. So we'll pull our e-stop out. These definitely look very angry right now. We'll reach over here and we hit the safety reset. And no doubt they did not come on. Everything else came on. These things are not going to reset. We've got to reset this module. A lot of you are probably like, well, Tim, why don't you just cycle the power on the stinking machine? Well, because cycling the power on the machine is probably one of our biggest downfalls when we're troubleshooting machines, because we learn nothing about it and we get in the habit of just cycling the power every time and we don't actually learn what the problem is. And yeah, I mean, really, arguably this semi-exercise we've worked several companies through to find out where their nuisance issue is. So now we don't want to cycle power on the machine. We got to find exactly what's wrong with it or what it needs right now. Okay, so I realized I was looking at the safety input fault recovery earlier. We wanted the safety output fault recovery. So if a fault is detected, the output is switched off, remain off. The following procedure to activate the output again. Remove the cause of the error, check. Command the safety output into the safe state, which would be a 0, check. And we're back to let the output latch time elapse. Yeah, that's not great. All right, well, we got a couple other options down here. Fault and status reporting, I think I've been to. Okay, we're on page 83, though. I can get back to troubleshooting the module. So we click it. All right, we didn't get to this exact one, but okay. I think we worked all that out. So what did I just say? I think it said 83. There's where I get lost on this. There we go. Troubleshoot the module. Oh, this is going to be really generic, I bet. It does have some really good info about the indicators. That's not how to reset them. So yeah, I'm going to try a couple different ways just to reset this to see what happens. So right now, we definitely have an angry fault, but everything is fixed. We go back to our module properties. Let's see, oh, that's weird. Why can't I inhibit the connection on that? Well, we do not want to hit the reset ownership. Now, I don't think you can reset the module if it's not inhibited, but let's try that. Because we are not inhibited. Yeah. So that's probably where I'm stuck at for today, because yeah, I'm not going to sit here and grind at this anymore. Really, that little bit of readback diagnostics would probably give us a lot. I do have one other issue that I can't figure out, and that is this little light here blinking. Now, I mean, if I was just gut feeling, that looks like some type of AC feedback. Now, what I'm doing here is these outputs are bipolar, so if we're looking at these, they're, whoops, pointing at the wrong one again. That's why I said we skipped every other one. This top one's a sourcing output, and number 1, that is a sinking output. And so one recommendation, or not recommendation, way that we can get diversity as part of safety is that you have diversity or variety in your types of outputs. That way there's less chance of there being a common fault. So yeah, we can take a single one of those outputs, since one of them is sourcing, the other sinking, or PNP, NPN, I guess what they're showing here. And so we got K1 going to 1, or we got one wire going to K1, and on that one, we're going to go to the minus of our power supply. The other one, we're actually going to the plus, and that gives us that diversity. But yeah, this one right here is twitching, like it's getting some AC feedback. That instinct would be that it probably needs some type of diode on it, but I would love, well, it has a diode on it. I have no idea why that thing's flashing. Anybody got any thoughts on that?